Okay, closed cylindrical tins are to have a volume of 1 litre, 1000 centimeters cubed. The curved surface area of the walls of the tin are to be made from rectangular sheets of length 2 pi r and width h without any waste. However, stamping out each circular end of pi r squared centimeters squared requires a square piece of tin of length 2r, and some tin is wasted. Express h in terms of r. Okay, so what we have here, we'll just do the sides of the. So we have a tin, or sorry, a cylinder. Okay, so cylinder looks something like this. So we have basically two circles, and then you have your cylinder. Okay. Now what we're going to make is a rectangle using the for the curved area, which is this here. Now the curved surface area is this is going to be height here and 2 pi r here. Okay. So what you said is they're made from rectangular sheets of length 2 pi r and width h. So look, that works perfectly for the curved surface area. Now what we're looking, no waste because it's a rectangular sheet. Now what's really difficult, however, is making circles from circles over a square sheet. Okay, so what we're going to do is we're going to make a square sheet of length 2r. Square piece of tin, length 2r. Okay, so what we'll do here is design our square, and the square is going to be 2r. Okay, so 2r and 2r. Now, what happens here is that if it's 2r, this means that if we're to have a circle in the middle, like so, and then eventually the circle will touch at all 3 points, roughly. We'll just move this a little bit, and then what we have there is our circle. Okay, so the circle needs to be made out of 2r because it's r across, and then it's another r across here, just to make one circle even. Okay, so what we got to do is we got to find out the amount of waste. Now the thing is, we're going to need 2 of these sheets and 1 of these sheets. So 2 for the top and the bottom, and 1 for the side. Now let's read the question. Express h in terms of r. Okay, well we know that the volume is 1000 centimeters cubed. So pi r squared h equals 1000. Therefore h must equal 1000 divided by pi r squared. Okay, so it's going to be 1000 divided by pi r squared. Now, next part. Express the area of the tin used in terms of r and h. Okay, so the area of the tin used. So this area here is going to be 2 pi r h. Okay, so we're going to use one of them. So area used 2 pi r h. Now we have to use 2 of these ones here, and it's going to be length by width, which is 2r multiplied by 2r, which is going to be 4r squared. We need 2 of these to make each circle out of, so we're going to use 8r squared. So it's going to be plus 8r squared. Okay, now we're on part 3. Express the area of the tin. Express the area of the tin in terms of r. So in terms of r means we're going to get rid of the h. It's going to be 2 pi r multiplied by 1000 over pi r squared plus 8r squared. Then we're going to cancel. The pi's will cancel. This r will cancel with this r. So what we're going to get is 2000 over r plus 8r squared. Okay, so that's the area of tin used. Okay. Now that we've done that, that's the answer to part 3. Tin plate costs around 0.03 cents per centimeter cubed. Find the radius, height and cost of the tin which will manufacture the tin most cheaply. Most cheaply is another word for minimum. And we want the surface area to be a minimum, or the volume area used to be a minimum. So we're going to use the ADR. Okay, and you can see what we're going to get here is going to be 1000. That's going to be 2000 r to the minus 1. Differentiate, and we're going to get minus 2000 all over minus 2000 r to the minus 2 plus 16r equals 0. What we're next going to get then is going to be minus 2000 all over r squared equals plus 16r equals 0. We're then going to cross multiply. We're going to get 2000 over r squared, and when we move this over this side, and we're going to get equals 16r. Then we're going to get 16r cubed equals 2000. R cubed therefore equals 2000 divided by 16. And we're going to get 125. R cubed equals 125. R therefore has to be 5 centimeters. Okay, so we know R is 5 centimeters. It wants us to find the height as well. The height, as we said, is 1000 divided by pi r cubed, pi r squared, which is going to be pi times 20. It's going to be 25 pi. 1000 divided by 25 pi. So 1000 divided by 25. $40. Okay, so it's 40 over pi. So h is 40 over pi. And now we finally have to find the cost. Well, we'll find out how much tin we actually have by putting R into the area formula. Okay, now let's make sure that it is in fact a minimum. So if it's a minimum, its second derivative is less than 0. So I'm going to differentiate this and just get rid of the workings for R equals 5. So differentiate it a second time. And what we can find out here is minus 2 multiplied by that is going to give me plus 4000 r to the minus 3 plus 16 equals 0. We're going to get 4000 over r cubed plus 16 equals 0. We know that r is 5, so it's going to be 4000 divided by 5 cubed. 5 cubed is 125 plus 16. That is greater than 0, makes it a minimum, is what we're looking for. Okay, minimum. So 4000 divided by 125 plus 16, 48. 48 is bigger than 0. Okay, now that we've established that, what we're looking back up, we know that it's a minimum, most cheaply a minimum. Okay, we have to find out how much area we actually used, so we're looking for the area formula. The area used formula is here, 2000 over r plus 8r squared. So what we do is just rub out this part here, and what we can say next is use r equals 5, and what we can find out is it's going to be 2000 over 5 plus 8 times 5 squared is going to be 400 plus 8 times 25. We get 200. 4000 plus 400 plus 200 is 600. Okay, so that's the area is going to be 600. But what we also have to find out is how cheaply can it be done. So it's going to be 600 centimeters squared is the area, but we know that each centimeter squared only costs 0.03. So we're going to multiply 600 by 0.03, and we're going to find out how much does it actually cost. So 600 multiplied by 0.03 is 18. Okay, so it's going to cost 18 cents to make. The stuff used is 18 cents. Okay, 24. A fuel storage tank is in the shape of a cylinder with a hemisphere at each end as shown. The cylindrical part has a length of h, and the hemispheres each have an exterior radius of r. The volume of the tank is 36 pi meters cubed. Show that h equals 108 minus 4r cubed over 3r squared. Okay, well, when you add two hemispheres together, what you get is a sphere. Okay, and the volume of a sphere, because we know the volume of the tank, so the volume of the tank is a volume of a sphere plus a volume of a cylinder. So it's going to be pi r squared h, and this one here is going to be 4/3 pi r cubed. And that's the total of the area of the tank, and the area of the tank has to equal 36 pi. The pi's will cancel immediately, and we're looking to find, I think it's looking to find h on its own. So looking to find h on its own. So what we're going to do is we're going to multiply both sides by 3. So I'm going to multiply this here by 3, top and bottom. This one here by 3, top and bottom. So what we're going to get is 3r squared h plus 4 pi r cubed plus 108. Okay, then we're going to bring this over to the other side. We're going to get 3 pi r squared h equals 108 minus 4 pi r cubed. Then what we're going to get after that is we're going to divide by 3r squared. So we're going to get 108 minus 4 pi r cubed all over 3r squared. Okay, and that's what we're asked to do. The total show that the total exterior surface area is given by pi over 3 r squared plus 72 pi over r. Okay, well, surface area, and we notice that there's no h's in the answer, so it means we're going to sub it out. So surface area is going to be the curved surface area of the cylinder. Curved surface area of this cylinder is going to be 2 pi r h. And then we need the surface area of two hemispheres, which is the same thing as the surface area of a sphere, because so it's going to be pi r squared. 4 pi r squared is the surface area of a sphere. That's them both added together. There's no h in the answer, so we're going to replace h with 2 pi r multiplied by 108 minus 4 pi r cubed all over 3r squared, and then we're going to take away plus 4 pi r squared. Now we see the answer is in two separate parts, so what we'll do here, it's no problem. So a is going to equal, now this r will cancel with this r here. 2 times 108 is 216 pi all over 3r. The next one is going to be minus 8 . It's going to be minus 8. Just a quick adjustment there, we had an extra pi, so this pi cancelled off that time, so when we subbed it in there is no pi here. Okay, so we're going to have 216 pi over 3r, and then we're going to have 2 pi multiplied by 4r cubed, which is going to be minus 8 pi. So this pi was never here in the first place because the adjustment made up there, so it's going to be minus 8 pi r cubed plus 4 pi r squared. So that's 8 pi r cubed all over 3r. Okay, so what we're going to get here is a equals 216 divided by 3 is going to be 72 pi over r, which is what we're looking for when we cancel that and that. The next part here is cancel this r with this r, and we get 8 over 3 pi r squared. So it's going to be 4 minus 8 over 3. And what we get there is 4 over 3, and that's going to be plus 4 over 3 pi r squared. Okay, so that's our area sorted there. 72 pi over r plus 4 over 3 pi r squared. Okay, find the minimum value of a is 36 pi centimeters squared. So the minimum value means differentiate this, okay? So differentiate the ADR. Now the ADR, this is going to be 72, and I'm going to bring the r to the top, and it's going to be r to the minus 1. differentiate, the minus 1 goes to the front, gives you minus 72 pi r to the minus 2. Bring 2 to the front and we get 8 over 3 pi r. Okay, then we're going to get a minus 72 pi over r squared plus 8 over 3 pi r, and this has to equal 0. So we're going to change sides. We're going to get 83 pi r equals 72 pi over r squared. We're going to cancel the pi's. We're then going to divide by 8. So the 8 appears down here. Divides into the 72 to become 9. The 3 disappears, multiplies by that. And then we're going to get 27. R equals 27 over r squared. Bring the r squared upwards. R cubed equals 27. R therefore equals 3. So now we know that the radius equals 3. Probably should prove it's a minimum. Differentiate a second time. So where is the ADR? So the ADR is here. Okay, so we're going to differentiate a second time. We know that r equals 3 already. So differentiate a second time, and what we'll get here is minus 2 multiplied by minus 72 gives you 144. Take 1 away from the power, r to the minus 3. This here is just a regular number beside the r. It's the same thing as differentiating 4r to get 4, so this is going to be 8 pi over 3. Next thing, it's going to be 144 all divided by r cubed plus 8 pi over 3. Now r cubed being 3, so it's going to be 144 all over 27 plus 8 pi over 3, and we know that that number there is bigger than 0. This makes it a minimum. Okay, so we've confirmed it's a minimum, and now all we got to do is throw r equals 3 into the area formula, which is here. So what we're going to get is the area equals 72 pi multiplied by 3 to the power 3 to the minus 1 plus 4 over 3 pi times 3 squared. Put all that into the calculator. So 72 pi times 3 to the power minus 1. 3 minus 1 will go there. Plus 4 over 3 multiplied by pi. And then it's going to be 3 squared. And what we get there is 36 pi. So the area of the minimum area is 36 pi. Okay, so 36 pi.